Welcome to installment 23 of writing a 6502 assembler in assembly language. Uh, what I want to do is I want to go back and look at that, well, not look at, but test the expression parser that I worked on in the last installment. But while I was working on that, I noticed that I have a problem and that my error routine that I call, which prints an error message on the screen, it is the way it recovers from the error is maybe not what I want. And in particular, that expression parser is part of the statement parser of the assembler. And when you are parsing in a statement and you have an error, so a syntax error of some sort, then it is very important to preserve a couple of things that could happen. So first off, when you have an error, some things that you don't want to lose information. And so, for example, if you have a label which is being defined, and then there's an error in whatever comes after that label, you still want the label to be defined. That's very important. You don't want to, because if not, then if as a result of that error happening, the label doesn't get defined, then what happens is that in the next line and the next line and the next line where that label is referenced, it's going to be an error every single time because it's not defined. Well, we don't want that. As long as we know that the label is being defined, if there's an error that causes the value of the label to not be certain or whatever, or there's just an error of another kind, we still want that label to be defined. And another thing is that we want to, unless it's absolutely impossible, we want to not let the error affect our idea of how many bytes of object code have been emitted. That is to say, our location count inside the assembly. If there's an error in an expression and we don't know the value of the expression because of that, but we still know that the expression is something which would generate a certain number of bytes of object code, well, then we need to make sure that those bytes of object code are generated, even if the value of those bytes is not correct because of the error. So those two things have to be preserved when you have an error in parsing. However, when you have an error in scanning, that's a different issue, and we really have to go back and look at each specific case of an error in scanning and figure out what's the best thing to do in that situation. And that's what I'm going to do today, or at least right now, is look at that. And I'm here in the file AS0, which is the main part of the scanner. And so what I'm going to do is I'm going to search for error and try to go find all the places it's used. And what I'm probably going to do is I have an error subroutine, and we'll come across that when we're searching here. Right here is the data that the error subroutine uses. It prints out some messages. Okay. So we see here if we jump to the label scan13, that means there's a bad character error. And again, here, jump to scan13 means a bad character. This is the main routine of the scanner. Again, I jump to scan13, bad character. And here's scan13. And what it does is it loads a message and jumps to error. All right, and here's the actual error subroutine. So the error subroutine in and of itself is fine. It prints out an error message, and it increments our count of the number of errors. That's all great. But this is the part that's the problem right here. The error subroutine also just starts getting characters from the input until it gets a new line or into file. And it just throws them away. That's not what I want to do. That's not going to be helpful. So what I need to do is remove this part of the error routine. And depending on the error, like in the scanner, when you get an error, you might do one thing, and the parser, when you get an error, you might do something completely different. The idea of recovery from the error depends upon what the error is and in what part of the assembler it's happening. So this sort of blanket approach of just throwing away input till we get to a new line is not okay. So we're going to get rid of that. That's the number one thing to do, is get rid of that. Okay, and this is the end of printing out the message. So we can just get rid of all of this stuff. Basically, it scans stuff in until it gets a new line. When it gets a new line, it ungets the character, right? I'm not sure why it does this. Okay, so it's going to get C, and it goes up here, and as soon as it gets like a new line or something, it'll go down here. It'll unget that new line, and then it will call scan, which gets it back. Oh, that's just for the purpose of counting new lines, I see. Yeah, that should have a comment on it, because it took me a few seconds to figure out what that one's for, right? This would be like reget new line to, increment line count. But I'm actually going to throw it away, so it does not that important. So this all just needs to go away. Bye-bye. Okay, and I don't think I need this error 9 stuff. I'm not sure why I have that. Let me just quickly do a search for it to make sure it's not referenced anywhere. Okay, it is not. All right, get rid of that. So now the error routine simply prints out the message now, and it increments the number of errors and returns. That's it. Recovery from the error, so it's just purely an output subroutine. Recovery from the error is going to have to be separate code. All right, and fatal, and it is actually a little bit odd before that fatal, well, no, it was a bit odd that as we'll see, yeah. There was a situation where you would call it error routine because you can't read from the file, and then the error routine itself was trying to read from the file some more, which doesn't make a whole lot of sense. So fatal just calls error, and then it resets the stack to what it was when the assembler was started, and then returns to exit to the surrounding environment, which in our case for now is the Orca command line environment. Okay, so again, I'm going to make sure that I'm searching for the string error. All right. And yeah, here it's scan 13. This is the error that happens if we get some sort of unexpected character in the source file. And that unexpected character can be one of two things. One, it can be a control character of some sort, which is not allowed in the source file. Or it can be some graphic character which does not play a role in the language input that we allow in the input language. So for example, like, I don't know, is there anything that we don't have? Yeah, like maybe there's no left braces in our source language. We don't allow left braces for any reason, right? Or maybe we, let's see, is there anything else? We have all these things. Those are all allowed, possible. I think so, yeah. There's actually not many graphic characters that are not allowed, but there are perhaps a few, like the left and right brace, for example. So anyway, if we get any of those, so any character which doesn't have any meaning as far as our source language gives us this bad character error. And so now that we don't... So the situation is now that the error subroutine is not going to recover from the error at all. We have to decide, well, what do we want to do? Okay, so we get a character, and we find out it's bad, it's no good. So we come down here, like it's a control character or a graphic character that we can't use. And we call error, so it'll print out a message. And what should we do after that? Well, I guess probably what we should do is just go on to the next character. Yeah, this character is no good, but let's just go on to the next character and hope it's okay. So if for whatever reason you tried to like assemble a file which was not a real assembly language source file, but a binary file, you would just get a zillion of these kind of errors. And then, yeah, who knows? Probably we can have it so that if you get like more than 20 or 30 errors, it'll just quit and say, look, that's too many errors, I'm not going to continue. But I think if you get a character that you're not supposed to get, like a control character or a graphic character, which is not used in our input language, then yeah, you just go on to the next character. And to do that, I guess, well, what do we return? Is there something we can return? Or do we just jump back and get another character? So we print a message. And I think we should just jump back up here to the top. Like, don't return from the scan routine, but just jump back up here and try to get something else. Like, yeah, we're not going to do this peak toke thing. I guess we'll just jump right back up to scan 0. That seems to make sense. This is where we first enter the scan routine and get a character. So for example, we get here, here's the situation where if we get 127, which is a delete control character, we're just going to jump down there to bad character error, which is going to print an error message. And then it should just jump back right up here to get another character. That makes sense to me. All right, so we'll jump, scan 0. Good, so that's taking care of that message. So we print a message, that error, that type of error, we print a message and then just jump back right up to the top of this routine to get another character and hope that it's something good. Okay, so now I'll just keep searching for, I'll get past this error thing here and keep searching for other types of errors. All right, so we have here hex error, and what this is what happens, we get this hex error comes if, for example, you get a $sign, which is the beginning of a hexadecimal number, but then what comes after it is not a hexadecimal digit in any way. So just a $sign followed by some character which is not a hexadecimal digit. And that's where we get this hex error. And so and it really only happens if you, like if you get a $sign, then a hexadecimal digit, then some character which is not a hexadecimal digit, that's fine. You just put that character back and you return the hexadecimal value that you received so far. So this only happens if you literally get a $sign and then no hexadecimal digit after it at all. And it seems to me that that would be very much like getting a bad graphical character. It would be like, like if you had just for whatever reason, you just had a $sign all by itself. That would be very similar to having just a bad graphical character, wouldn't it? So I think we might want to print out this error here, right? Go ahead. Let's see, how do we get here to bad hex? Okay, we get the bad hex by getting a character, and we say, okay. So if we get a bad character, we jump to first flag, basically. Right? So if Y is not 0, that means we got the getC didn't return a valid character. There was some error there, so we go to first flag. Then we compare against an ASCII 0 digit. And if it's less than that, which means it's some sort of control character, we get our first flag. So obviously this label first flag is the label we go to when we get something which is not a hex digit. And what it does is say, it just loads this value right here. And this value can be set from outside to say whether or not the first digit has been read or not. So if this first flag is set, that means this is should be the first digit of the hex number. And if we didn't get a hex digit, we jump to bad hex. Okay? And what happens here is that if we do get a valid hexadecimal digit, then we're going to store, okay, multiply. Oh, okay, this is a loop which multiplies, it shifts the token value left 4 times to multiply by 16. And then after that, x is 0, and we store that 0 in first flag, which means from now on we know it's not the first hexadecimal digit. So we only come here if the first character after the $sign is not a hexadecimal digit. Okay, so we'll print that error. I think that's fine. But I'm thinking that after we print that error, we should probably just try to go back and get another token. I mean, in other words, treat it like that was a bad character. But I do want to print the message out about it being a bad hexadecimal constant to not confuse someone who receives the error. They see that, they should know that, oh, that $sign, that's supposed to be a hexadecimal constant. So I do want to have the different error message here. So it jumps to get hex 2. And where do we return out of all this? Out right here. Okay, Lutinum RTS. Yeah, I feel like what I want to do here is print out the message that this is a bad hexadecimal constant, and then just ignore that $sign and go back and print out the I go back and just try to get another token. The only other real possibility I have is that I return it as I print the message, but then I say, okay, fine, I'm going to pretend that there was a hexadecimal number there anyway with the value 0 since there are no digits. I mean, that's not necessarily a bad idea. Maybe I should do that. So in other words, if I were to get just a bare $sign, I'll say, okay, to me that looks, I'm going to pretend that is a hexadecimal number with a value 0 because it has no digits, and return it as that. Is either that or I just skip it and move on and try to get another token. I think I'll do the former. That is to say, I'm going to pretend it's a hexadecimal constant with the value 0. Okay, so then that means here I'm going to JSR error, and then after doing that, I'm going to get a $sign back in the accumulator because I'm going to unget that thing, and then I can go back up to get hex 0 right here, in other words. So I print out the error message, I get a $sign into the accumulator, go to get hex 0, which ungets that $sign, puts it back in the input, and then it returns a number with value 0 as a hexadecimal. Okay, that looks nice. All right, let's keep going. More errors. okay, here's invalid numeric label error. And this happens when we have a numeric label. Let me just make sure I'm going to see. Okay, it comes from getDex7, which we come to here. These are get to get. Yeah, okay, so it's for everything. So in other words, if we have something like this as a numeric label, or we have something like this as a numeric label, and the issue here is a reference to numeric label. And the issue here is that this number has to be from 0 to 9. It cannot be any two-digit number like 12 or something like that. And that's where this comes in. Okay, so this is actually a little bit of a difficult problem to solve. So say, for example, someone has this in their code because they didn't realize that numeric labels have to be from 0 to 9. Then in this case, there's really, like I said, preserving labels is an important part of handling errors, but there's no way to preserve this because you just can't have a label like this. So I think this is going to be a situation where really there's not a whole lot we can do about it. Like we get here, we say, okay, you know, and presumably if the programmer did this on purpose, if it's not just a typo or something, then later they might have, you know, something like that. So we're going to get this error here, and then get the same error here. And I should, yeah, probably take care of both of those cases. You know, I mean, in other words, think about in each case what to do. If it really is the situation that, well, we're not going to define this. So here, when you do something like this, it's an undefined label. And so I feel like this one ought to probably just from a point of if I see this in the code, now I'm not thinking about the scanner here, I'm just thinking about the assembler in general. It ought to see this as branching, attempting to branch to an undefined label. And branching to an undefined label is of course an error, but it's not a huge disastrous error. It basically allows us to say, okay, we're trying to branch somewhere, but the place we're trying to branch is no good. So at the very least, though, we're going to get this idea here that that this branch of not equal instruction can be assembled. Because even if we don't know the label, we can say, well, we're going to branch, there's supposed to be branches somewhere, so there's 2 bytes to be emitted here. So we don't want to do something that prevents us from in the parser section later, going ahead and assembling this. And actually, I would prefer, I suppose, that in this part of the scanner that this is accepted. This is accepted in the scanner. It's only not accepted in the parser. And then the parser says that's an undefined label. I think that's the thing to do. So actually, this is the part that's a problem, which means we have to change this code a little bit, because in this case of something like this, we do want to go ahead and return this as a numerical label, but with a bad number, so that it will say, okay, that's an undefined label in the parser. All right, where's the place where we return the token? I jump for label, backward label. Where's for label, backward label? Somewhere else. Okay, that's somewhere outside in a different source file. Okay, so we'll have to look at that later. But for right now, what I want to do is this comparison to make sure that the number is less than 10. If it's greater than 10, it goes down here and generates an error. That should only happen in the case of there being a colon after the number. Right? So I have to rearrange this stuff a little bit. Okay, total 1, branch not equal to get date. Okay, so this whole thing is just checking, it's checking the number first. And I don't want to do that. Okay, so A is containing the character which comes after the number, right? The colon or the B. We push that. Actually, we don't need to push it though. Not at the moment. We need to compare it with colon. If it's not equal to colon, we can go all the way down to get dec2 immediately. Well, we'll compare it against F or B. Well, I guess it already knows it's colon F or B. Okay, so now if it is a colon, then we'll check the number to make sure the number is less than 10. And I'm not quite sure why did I push A and pull A instead of just using a different register to check these to check these things. That's a good question. Is X or Y being used? Well, they're used here. Looks like they're available. Okay. So, yeah, I hope this doesn't screw something up. But looks like I could just use X here to do this comparison. That way I don't have to push A and pull it. Okay, so now we look to see if it's the character after the number is a colon. If it's not a colon, we go down here and it's got to be F or B in this case. So we go ahead and jump to for lab or backward lab. If it is a colon, we check to make sure that the number is less than 10. And now we don't need to do this now. Okay. If the number is less than 10, we'll just jump to numlab. If the number is greater than or equal to 10, we'll jump down here and give an error. And we don't actually have to have the pull A now. Okay, so the error is only happens if you have, in this situation right here. It doesn't happen in this situation here. This one here. This is not seen as a scanner error. This is seen as an undefined label error, which we'll have to handle later. But this one here will be seen as a scanner error. Although I'm not sure that's even true. Well, it has to be an error of some sort. I mean, we can't make a numeric label with a value of 12. But I'm thinking, do we need to handle it here, or do we should go just handle it in this numlab place? So if we handle it here, then we're going to print the message invalid numeric label, which is fine. But then what do we do? I think we just return as if we didn't get a label at all. We just say, hey, there wasn't a label. That's what we pretend. We pretend like there's no label. That would be the right thing to do, because then any reference to it would be undefined, which we already know it's going to be anyway. Okay. So I'll change this to JSR for a moment. And so now we have to figure out how do we make this work so that it seems like there was no label at all. Okay, so this is in get decimal, and this is in the scanner subroutine. So the scan subroutine calls get decimal. So what we really want to do is we want to print out this error message, and then we want to pretend like we didn't see anything at all. There was no label. So then we're going to go back and return a token. So it looks to me like what we want to do is here. Let's think about it. There's a routine called scan, which has blah, blah, blah. And then there is a label there called scan 0, where it starts to collect characters to try to build a token. Okay, and then at some point it saw it's a digit, right? And so it called get deck. Now, I don't know for sure if it said JSR get deck or whatever, but it called get deck. And then get deck found out actually it's looks like a number, but it has a colon after it. So it's actually a numeric label. And this numeric label, however, does not have a value between 0 and 9, so it's an invalid numeric label. So what we need to do is we actually want to jump back up here after printing the error message. But before we do that, we're going to have to check and see, is this I think it's a JSR get deck, but we need to make sure what it is in any case. So let's search for it, get deck. Oh, it's a jump get deck. That's actually very convenient. Jump get deck is super convenient. Okay, and the reason that's super convenient is that what we can do after we JSR error is simply jump to scan 0. We don't have to worry about the state of the stack. The stack is fine. We just jump to scan 0. And pretend like that invalid numeric label never happened. Okay, so that looks beautiful. I hope it's beautiful. I hope it works. All right. Here's the next error. This is a character constant error. Okay, and it's at get CHRL 2 or 3. Okay, so we get a bad, so I guess this is the situation where we get a single quote and then we get some bad character. Like, Yeah, we have a single quote when we come in here. We get a character. If it's no good, we can't get a character, we get a 2. All right, that would be the situation, for example, if you have an end of file or something. And then if that's not the case, we check and see if we get an escape sequence. If we have an escape sequence and that comes up with something bad, we're also going to go down there and say bad character constant. That's what this is all about here. Otherwise, we're going to check for new lines and control characters and stuff like that. Okay, if we actually, if we get a new line like line feed character, character string character, we'll go down here and say bad character constant. If we get a control character, then we go down to here, which jumps to get strl 8. And what this is actually just it's a different error. It means an unterminated character constant. Okay. Then we're going to push the character we get and see, did we get a single quote? Okay, I just thought of something this doesn't check for, which is that if you get a single quote followed by another single quote immediately, that would be a bad character constant as well. It would be an empty character constant, so we don't want that. So we'll put that in there. Okay. Actually, that just seems a bit odd. I think these things are a bit wrong, because get CHRL8 jumps to get STRL8, which is down here somewhere, and it prints this CHR error, right? And CHR error is, oh, bad character in input. Oh. Bad character in input. So that's the idea if we get a control character basically inside a... Okay, that's the situation where we get a control character inside a character constant is where that comes from. I see, and that's exactly what it is. So delete character 127 or any other control character besides new line or character turn. Those give us the bad character error, like just as if it were any other bad character, you know, like I said before, a control character in the file. Okay, so there's no unterminated character constant. That was a mistake of mine. But we'll call it bad character constant if it's a single quote followed by a new line, a line feed, character turn, or another single quote immediately, or some thing which is bad from the escape sequence. Although then you get the issue, what if you have a backslash followed by a control character? Yeah, that really should probably be a bad character input, not a bad character constant. Okay, so anyway, this error here is the error that occurs when you have a character constant which after the first single quote you have a new line, character turn, another single quote, or something like that. Yeah. So after it jumps to error here, what should it do? Well, if it got a new line or character turn, it should probably unget those. So if getC doesn't work, we go there. If getC doesn't, if we get something horrible from getEST, we go there. Otherwise, if we get a line feed or a character term, we go there. If we get a single quote, we go there. Well, we don't want to unget a single quote. That would be wrong. But we probably should unget these two things. And we go here only in the case of, right, we push A, which is the character constant, whatever is inside the character constant. Then we're looking for the single quote at the end. All right, if something wrong happens from getC, like, like an IO error or something, then we go down here and pull the A back out and throw an error. There's actually a couple things to think about here, because there's issues of just getC not working, right? Getting into file basically and going down there. This issue, I think here, if we go to getESC and then we compare Y to 0, this, and it's not 0, that's going to be another EOF. These are EOF conditions here and here. These are end of line conditions, not exactly the same thing. This is an empty character constant issue here. And here's another end of file issue here. So for all of the end of file issues and for the end of line issues, it's safe to unget I believe it is safe to unget the character, because then we'll get it back next time. And that just reminds me, I did an unget here, right? Where I ungot a $sign. Do you remember that? But I think when you unget, it ungets not only whatever is in A, the accumulator A accumulator, it also ungets whatever is in Y. And so I had better do that to make sure it doesn't actually unget some with something in Y, which then would come back looking like end of file. That would not be good. I can check on that in a minute, just to make sure it's right. Okay. Okay. So get CHRL2 there. There. Those are both end of file, end of line, end of line, end of file. So in all of these cases, CHRL 3, that's maybe not right. Let's separate this out. Okay, first, in the case where we call it get CHRL2, when it is an end of file node, we can call ungetC. And put that end of file new line back on the input. Then we can produce a bad character error Okay, and so this is the case of single quote and then into file. Should we return a token here, or just skip this thing? In the case of single quote into file, single quote into line, we should just, I think, ignore that single quote and then find some other token, which means that we would JSR to error, and we would then jump to scan 0. Okay, I have to make sure that get CHRL is also jumped to. What is it? Get CHRL. There we go. Yes, it is jumped to. Okay, that means I'm free to here just jump up to scan 0. So we unget the new line, unget the into file, print out the message bad character constant, then jump up to scan 0 to try to get another token, which of course we're going to get the into file new line that we just ungot here. And that's also the case for this one here, get CHRL3. But the only thing here is we've pushed this character on the stack. So we somehow need to get that thing back off the stack. So maybe we'll just do it like this. Okay. So if y is equal to 0, that means we did not get an into file from new line. I mean from get C. We'll go to get CHRL3. All right, and this will be get CHRL3 here. And this will not be get CHRL3. That would just get rid of that line. Okay, now this is the situation now. Here, let's get rid of that too. Where we have an into file. So we're going to pull A that we pushed there. Okay, and then jump 2. Yeah, I don't think I know the state of the flag, so just jump to get CHRL2. Oops. Okay, so if we don't get in a file, if we do get in a file, we'll just pull A, jump to get CHRL2, which will print our message and everything. If we don't get into file, then we'll go down here, which compares what we got to be a single quote. If it is equal to a single quote, we'll jump down here. Otherwise, we'll fall into this error handling code because we didn't get a single quote. But that's actually a different issue. So we have to be careful with that. And I think I might rather say if it's not a quote, then goes somewhere else, go to an error problem. If it is a single quote, then we need to do this stuff. Let me just retype. RTS. Okay, pull A, store toke file, load 0, store toke plus 1, good. Okay. So, if we get something bad that is not a good character, we go to get CHRL2. Well, if we get end of file, new line. End of file or end of line. Right? End of file in the get escape function, subroutine, new line, and we also have a single quote going back down here, but that's probably going to have to change. If we don't get any of that stuff, if we get a control character, get CHRL8, which is going to be just a bad input character. Then we assume we've gotten something good, we push it, we get C, and if it is if y is not equal to 0, that means it's a it's an end of file, and we'll pull that thing we just put in there and jump to get CHRL again into file. If we did get something good, we're going to compare it to a single quote, and if it's not a single quote, go to the error prop thing. But we have a different error thing here. We need a different error handling code 0, 3, 2, 1. Okay, let's just call it get CHRL4 here. And there are two places we're going to go here. This is the case of single quote with nothing in between. Okay, that's end of file, end of file. Oh, I'm sorry. This is the case of single quote, nothing in between. This is the case of single quote followed by a good character followed by something which is not a single quote. Those are both bad character constants. So this one here is the case of an empty character constant. This is the case of a character constant with two ASCII characters in it, which is no good. Okay. And what makes those different is that in that case, we don't want to necessarily unget anything. Right? We don't want to unget anything. Instead, in the case of a just single quote, empty character constant, we're actually all good. We should probably return that as a token. In other words, return it as a character constant with value 0. I think that's the best thing to do there. Recognize a character constant because we have quote, but generate error to say, hey, this is no good because it's empty. Okay. So actually, in that case, we probably should just go here. I think that's a good idea. We're going to generate an error, so it really doesn't matter if what value this character constant, this bad character constant has. So I think it's okay just to leave it as being whatever it happens to be. Okay. Okay, so if we get just single quote with nothing in between, it's going to come down here, which means it's going to, the token value is going to be of a single quote. But it's going to generate an error, or no, it's well, we need to generate an error, but it's not right now. Okay, I need to make it generate an error. I don't want to do that. Okay, it needs to produce an error. Well, so I could do like this. Okay, and this then could actually be get CHRL4, and this one could be 5, and then up here 5. So if you get single quote, you print the bad character constant message and record the error. Then you load 0 and go up here, which stores a 0 in Tocfal and returns tnum. So it returns it f as if it were a actual valid character constant, but with a value of 0, and it prints an error message, which means it's not going to even go into the second pass of the assembler. At least I don't think so. All right, and now you have the situation where you get a single quote, then some character, which looks like it could be the start of a nice character constant, but then you don't get another single quote immediately thereafter. That's this issue, this situation here, and that's like a more complicated situation, perhaps. In this case, we probably want to collect characters looking for a single quote, because maybe the user thought you could put 2 characters inside a character constant. After all, it works in C. And so that might have been their idea. So if we can look for a single quote, okay, so what we can do here is we can JSR get C. We have to make sure that if y is not 0, then it's into file. Okay. And if it's into file, we're going to want to unget the into file. Which means we can just go straight down here. Yeah. Okay. So if that's not equal to 0, we can jump straight to get CHRL2. That's fine. Now we compare to line feed or carriage return. If that is line feed, we can also jump down there, unget it, print the message, and exit. If it's carriage return, we can also go down there. We'll unget that. And then print the error message and go scan again. But the scanning again will just get us that end of file or end of line, which is fine. Okay, and now we need to compare and see if it's a single quote. If it's not a single quote, we want to keep scanning. So we'll go up to get CHRL6. If it is a single quote, then we can drop right down here and return it again as a no, we don't want to drop right down here, do we? Yes, we do. We'll print out an error message and then put a 0 in the value and token value and return it as if it were a character constant. So we'll say bad character constant, but we'll return the character constant token, and that looks like what I want to do. Okay. So I think that is now fine. Okay, now we have these. This is a case where you have a control character inside a character constant or inside a string constant. All right, and it ungets the control character, apparently. Prints out a message, and then jumps to error. So we should treat this exactly like we treated the control character before, I think. Well, maybe not exactly, because here we're actually inside a character constant or string constant. Well, let's just go back and look at that for a second anyway, okay? All right, here's the first place. We did that, we JSR error, and then jump to scan 0. Okay, and let me go just check one thing here with get strl. I mean get strl. Get strl. Yes, it's a jump. That's good. Get what is it? CHR error. Okay. Here we go. Oh, sorry. Next one. Here. So what I did up above, here, let me look again. I did not unget the bad character, the controller character. I just skip it. I print out the message and then go back at the top of the scan loop. So I think probably I don't want to unget it here also. Get strl8. Okay, jump get strl8. Yeah. Yes. I don't want to do that. I don't want to unget it. I want to just have it be gone. The control character that I don't want. Okay. But the problem here is it's probably not the right thing to do in this case that I just go on and try to get, go back as if I'm scanning a token from the beginning here, because I'm inside a character constant or a string constant. So it seems to me that what I should do is look for the end of the character constant or string constant. Which is, yeah, that might be the right thing to do. Okay, this stir error, that's an unterminated string literal, I'm pretty sure. Get strl9. What happens? Yeah, I'll just go up here and look for it. Get strl9. Okay, it goes from end of file, end of line, end of line, end of file. Yeah, it's just that. It's an unterminated string literal. So if you have an unterminated string literal, I think what we would want to do is return it as if it were actually a string literal with all of the characters accumulated up to that point. But we need to print an error as well. And here onGet is correct. We're onGetting the new line or the end of file. So we probably here we need to print the error message, record the error. And after that, we need to go up here, and this is the end of the get string literal where it stores the thing. Okay, so it gets X from get strl1 plus 1. It's right here. Okay. So we imagine we've done that every time. We now get, we find that we get a line, new line or end of file inside that thing. We go down here. So this was for the previous one, and we incremented that. So it looks like this is that the value here is correct. That we can just go ahead and store the 0 here. Oh no, here. The value here is correct, so we can just go here, get strl2, which terminates the string. Yeah. So what happens is if you have an unterminated string, imagine the last actual good character in the string before the end of line character. Then what that's going to come through here is going to say load X with whatever the current value of X is, store that good character in the text buff, increment this byte here to advance to the next space. It didn't overflow to 0, so we'll go back up to get strl0 and get another character. And it gets another character, and it turns out to be a new line. So then it goes down here and prints an error message. But then what we'll do is we will jump up to get strl2, which will then load a 0 into the accumulator. It will get this byte, which has already been incremented to point to the next location in the text buff, and it will store the null there, and then move the X, which is the length of the string, into Tocqueville and return it. Good. So if we have an unterminated string, what will happen is it'll print the message, but then return everything which has been generated up until that point in this line as a string constant. And what that means is that, you know, if for whatever reason there was something like hello world and then a new line, there will be a string hello world. Now, if the person who's writing the code was mistaken and thought this is how to put a new line in his string, and so he now continues, you know, hello world and then what's your name or something like that, and then tries to be like that, okay, then this will produce a string constant, and then it will end here. And then when it starts the next line, it'll get an error saying, hey, this is, you know, an invalid label. It'll see this as a label, and it'll try to then, you know, evaluate an expression, which will be undefined and blah, blah, blah. And then maybe we'll get an error here from a character constant. I mean, it'll get other errors here. Okay. And I said in this case where you're inside a string constant or a character constant and you have a control character, basically. Some bad character. It's going to be a control character. It's the only kind of bad character you can have in there because there are no bad graphic characters inside a string constant. Then I said probably what we should do, or what I should do, is I should try to scan for the end of the control character or string constant. But if I do that, do I include this in there? Actually, I think what I ought to do here is suppose there's a control character in a string constant. Maybe it's accidentally there. Maybe the editor that the programmer has used, makes it possible to insert a control character by accident, like a tab inside a string constant, for example. Which, of course, in a string constant, if you want a tab in there, you should do here is a tab and then \t after tab. But if your editor allows you to insert a raw tab character in there, then we would get to this situation here. And maybe we should just skip it. Just say, okay, I see there's a character there. I'm not going to put it in your string constant, but I'm just going to continue looking to see if you finish your string constant. That probably is the right thing to do. Okay. So we're going to print the message about a bad error, a bad character. But then we just should go right back up here, I think, to get strl0. I think that makes sense. Okay, that means that we can't use this though from the character constant code. It has to have its own thing, but it's going to be basically the same. Instead of jumping down there, okay, record the error, and then what should we do now? We got a single quote, we got some sort of control character, which is not what we want. I think we should just go back up here, to be honest. That way, if someone said single quote and then they inserted an ASCII 9 and then another single quote, what's going to happen is they get the single quote, they get the ASCII 9, go down here, say, hey, there's a bad character in the input, right here. All right, then it's going to go up here. It would get then the single quote, which it calls it in here and print out the error message, bad character constant. Maybe that's not it. Maybe what we have to do is treat this the situation where we want to just scan for a into the character constant. That is this situation right here. I think that's better. So if you have a single quote, then like an ASCII 9, then you're going to say, okay, there's a bad character in your input. And then we're going to jump up here and scan for the single quote, which ends the character literal. We could still get another error in that case, a bad character constant. That's fine. I think this is where we should go, get CHRL6. So you could say, why even go here at all? We could just have it go straight here. But I like giving the information perhaps to as an error message that there's a bad character in the input. Not just a bad character constant. Because what if they had something which looked like this, to them it looks fine, but they don't know there's actually a control character in here which is not being displayed, right? Then it would be useful for them to get this message that there's a bad character in the input here. Otherwise, they would see this and they would get the message bad character constant. They would say, why is it a bad character constant? It doesn't make sense to me. So I think I'll leave that like that. All right. Go down here and what is this? Oh, it gets you returns character from file. Okay. Okay, so that's all of the places in AS1 where we use the error routine. So let me save that, load AS2, and look here. Okay, this is an unexpected token error. Oh, I didn't mean to look at AS2 anyway. I'm sorry. I meant to look at AS1 first. And it's not found. That's good. We don't call the error routine from AS1. Now I can go back to AS2. Oops, there we go. Unexpected token. Now these are parse errors. These are syntax errors here, and these are different. These will be handled differently than we just handle those scanner errors. And so I think that, yeah, that's kind of the end of this installment. We handled the errors from the scanner in a better way than they were being handled. And the next thing to do is just keep working on this on the statement parser, but make sure we handle parse errors in an appropriate manner, which, as I said, will mean that we don't want to lose track of how many bytes we're emitting, and we also don't want to lose the definition of labels and symbols. So that will be it for today. If it's super boring, sorry, it's necessary, and I want to record everything I'm doing. So next time, hopefully things will be more exciting.